Alright, so far, except for the problems involving the fractions, we've basically been reviewing things that were presented in pre-algebra. From here on out, we are going to be getting into new material, and so it is very important that you go ahead and make sure that you understand it, and if you don't, please make sure that you ask in class. The next thing that we want to look at is Introduction to Inequalities. In this presentation, we're going to be talking about different ways to represent answers. And so we will be looking at it here, but we will also be looking at it in the next presentation as well. So, for this section, we are going to be working with our number lines again. And so the first thing that you need to know is know how to plot numbers on the number line. Upon completing this presentation, you will be able to graph inequalities on the number line and write the solution to an inequality using interval notation. Interval notation is something that you've probably never seen before, and so this will be a new concept. So, the first thing that we want to talk about is graphing inequalities. I'm going to go through the procedure here, but we will review it as we start looking at problems. So the first thing that we want to do is identify the location of the critical number or numbers on the number line. The critical numbers are the numbers that are in our inequality. We call them critical numbers because on either side of these numbers, things change. For instance, to the left, it may be a true statement. To the right, it can be false, or vice versa. From there, we want to shade the side that corresponds to the inequality. To the left, if it is less than, or to the right, if it is greater than. We're also going to be introducing the concept of or equal to. And so less than or equal to will be to the left, greater than or equal to will be to the right. Our final step is to identify what happens at the number. You can use the old school notation, which is open circles and closed circles, but I'm going to present a new notation, which is parentheses and square brackets, only because this corresponds to our interval notation. So we are going to use a parenthesis if it is a strict inequality, meaning that it is less than, strictly less than, or strictly greater than. We use a square bracket if the critical number is included for our less than or equal to and our greater than or equal to. And we want our parenthesis or our square bracket to open in the direction of the shading. So let's look at the following examples. So our first step is we want to plot the critical number. For example A, my critical number is 3. So I'm going to put a 3 underneath the tick mark that I want. Now I'm not going to put a dot on this one, only because remember we're going to use a parenthesis or a square bracket. From here, I want to shade the side that corresponds to the inequality. Where are the numbers that are less than 3? Well, the numbers less than 3 are going to be to the left. So I want to shade everything to the left of 3. From here, I want to indicate what happens at 3. Is it included or not? Is 3 less than 3? No, it's not. It's actually equal to. So it doesn't actually satisfy this statement, which means I want a parenthesis, and I want my parenthesis opening towards my shading. And that is the graph of x is less than 3. For the next problem, let's look at x is greater than or equal to negative 1. So, again, I want to identify where is negative 1 on the number line. Negative 1 is 1 to the left of 0. So I'm going to put a negative 1 underneath there. I want to know what side should I shade. Should it be to the left or to the right? Here, the numbers that are going to be greater than negative 1 are going to be to the right. So I want to shade to the right of negative 1. And then I want to indicate what happens at negative 1. So at negative 1, is it greater than or equal to negative 1? Yes, it's equal to, so it does satisfy the inequality. So I want a square bracket. Make sure that your square bracket and or your parenthesis is on the tick mark. Notice that when I first drew it, it was kind of a little to the left. That would not be considered good because it does need to be right at negative 1. Okay, the next example, this is a 3-part inequality. And so for the 3-part inequality, we're going to label both critical numbers on the number line. So we have negative 1, which is 1 to the left, and we have 3, which is 3 to the right. Now a 3-part inequality basically is you have two conditions that we're trying to satisfy at the same time. I want to know where are the numbers that are larger than negative 1, but are also less than or equal to 3. And those numbers are going to be in between negative 1 and 3. You will never shade the outside branches for a 3-part inequality, only because this is an and statement. And if you're shading the outside branches, that's actually an or statement. You can be less than negative 1 or greater than 3. You can never be both. So when we talk about a 3-part inequality, it's always going to correspond to the middle section. From here, I want to go ahead and identify what happens at each number. So at negative 1, do I want a parenthesis or a bracket? Is it included or not? Negative 1 is not included, so I'm going to use a parenthesis at negative 1. 3 is included, and so I want to use a square bracket at 3. And this is your graph. Okay, for D, we have x, negative 5 is greater than or equal to x. So I'm going to start by plotting my negative 5. Negative 5 is 5 to the left of 0. And now I want to know where are the numbers such that negative 5 is less than or equal to. So just think of a number that would satisfy this inequality. Is negative 5 less than or equal to 0? Yes, it is. Is it less than or equal to 1? Yes, it is. Where are those numbers in relation to negative 5? They are going to be to the right. So I want to shade to the right of negative 5. What happens at negative 5? Do I want a square bracket or a parenthesis? Is it included or not? Since it is included, I'm going to include a square bracket opening towards the shading. For our final example, we have 6 is greater than x. I'm going to start by plotting 6. 6 is 6 to the right of 0. I want to know what direction do I want to shade. Where are the numbers that 6 is greater than? Well, for instance, just try some numbers. 2. Is 6 greater than 2? Yes. -4. Is 6 greater than -4? Yes. What about 8? Is 6 greater than 8? No. So 8 is actually to the right of 6. This is not the area that I want to shade. 4 and -2 are on this side, and they did satisfy the inequality. And so that is the direction that I want to shade. So I'm going to shade to the left. And then I want to know what happens at 6. 6 is not included since this is a strict inequality. And so I want a parenthesis. So one of the reasons that I wanted to look at D and E is to point out that you do want to be careful when looking at inequalities. One of the basic rules is if the variable is on the left, then you can follow the arrow. But this only works if the variable is on the left side of the inequality. For instance, if we look at A, we have x is less than 3. Since the variable is on the left, I can follow my arrow. I want to shade to the left. For B, since my variable is on the left, I can follow my arrow and I can shade to the right. But if your variable is on the right side, then you do need to be more careful. You do need to actually think of numbers that will satisfy the inequality. Or what you can do is rewrite the inequality so that your variable is on the left side. So for instance, -5 is less than or equal to x. If you want, you can flip this around, but you do need to make sure that your crocodile mouth is still opening towards the same quantity. I still want my crocodile mouth opening towards the x. Now that I have my variable on the left, I can follow my arrow, and my arrow says to go this way. Similarly, with 6 is greater than x, if I rewrite this with my variable on the left, I still want my crocodile mouth opening towards the 6. So if we have our variable on the left now, it tells us to go to the left. When working with just graphing, this isn't an issue, but when we start talking about solving linear inequalities, this is one of the reasons that you may want to always put your variable on the left side. If you do decide to put it on the right, make sure that you are very careful and that you are checking your inequalities with your graph. So this takes care of graphing inequalities. The next thing that we want to look at is interval notation. Now, interval notation is just a shorthand number line. It is recommended that you always graph on the number line before writing an inequality in interval notation, just because it is a shorthand number line. So, when working with interval notation, what we're going to do is we want to identify the leftmost value and put a parenthesis or bracket opening to the right. For instance, this symbol or this symbol on the left side, depending on whether the value is included or not. If there is no leftmost value, meaning that it goes forever to the leftmost symbol in your interval notation is -infinity. Infinities will always have a parenthesis with them, since you can never equal infinity. Once you get there, it moved further away. The next thing I want to do is write a comma. And I'm going to write the rightmost value and put a parenthesis or bracket opening to the left on the right side, depending on whether the value is included or not. If there is no rightmost value, meaning it goes forever to the rightmost symbol in your interval notation is infinity, and you will want to use a parenthesis to enclose it, again, because you cannot equal infinity as well. So let's go ahead and look at some examples so that we can kind of make more sense of what this says. All right, so here are the examples that we worked through previously when we talked about graphing. So now we want to talk about the interval notation. So once you have your graph, the interval notation is very easy to come up with. I'm going to start with example C, as it has a left and right value. So my first thing that I'm going to do is I'm going to start by writing my left and rightmost value, and I'm going to separate them by a comma. So my leftmost value is -1. My rightmost value is +3. From here, I want to encase in parentheses and or brackets. And basically, all you have to do is look at your number line and see what symbols did you use there. -1, we had a parenthesis that was opening to the right. We're going to use the same symbol on our interval notation. For 3, we had a square bracket opening to the left. We're going to use the same notation in our interval notation. And so our interval notation is parentheses, -1, comma, 3, and a square bracket, and you're done. Interval notation, as I said, this is a shorthand number line where all we're keeping is the numbers or the symbols that we need without actually having the number line. So this is saying that I want all of the values between -1 and 3. -1 is not included, and 3 is. So let's look at some of the other examples. Let's look at example B. Example B, what is the leftmost value of my shading? It is -1. My rightmost value is infinity. This goes forever to the right, which is the positive side of the number line, and so it's a positive infinity. Now that we have our two symbols as far as our left bound, our leftmost value, and our rightmost value, we want to go ahead and put in our parentheses and our brackets. -1, we had a bracket on our number line. We're going to have a bracket on our interval notation. Infinity, remember that you cannot equal infinity, and so you cannot use a square bracket around infinity. This is going to be a parenthesis. There is your interval notation. So now let's go down to example D. Example D, we have -5 is less than or equal to x. If we look at our graph, what is our leftmost value? It is -5. And our rightmost value, again, since this goes forever to the right, it is a positive infinity. My -5 will have a bracket. My infinity will have a parenthesis. Make sure that these are facing each other when you have your interval notation. Okay, so now let's look at example A and E and see what we can do with these. Example A, we have x is less than 3. So pay close attention. What is the rightmost value of the shading? Well, the rightmost value is 3. So I'm going to put that after my comma. The leftmost value, this goes forever to the left, and so it is an infinity. But note that we are on the negative side of the number line, and so I do need to write negative infinity. Finally, what symbols are we going to use? Negative infinity will have a parenthesis because it is an infinity. 3 will also have a parenthesis because that is what we used on our number line. And we're done. Try example E. Example E, my leftmost value, since this goes forever to the left, my leftmost value will be negative infinity. It will have a parenthesis. My rightmost value is 6. And since it had a parenthesis on the graph, it will have a parenthesis in the interval notation. So this is kind of an introduction to interval notation, and I will continue to kind of test you over it. It will not come up on the final, but this is going to be something that you will need to know when you get into your later math classes. It is a fundamental thing that you will be asked to do whenever talking about inequalities or a set of values. So now try the following problems on your own. See what you come up with. Bring your answers to class, as well as any questions that you need to be clarified.